Hi, today I'm going to show you how to get root access to the Lupin machine, which is the second machine in the Empire series on Vulnhub. I did another video for the breakout machine, so if you're interested, you can go and check that one out. As always, I hope you find my content helpful and are able to apply what you learn here to future challenges. Let's get started. First things first, let's identify our target machine. Use the command ifconfig to get our host machine's information, and then use the nmap tool to scan that network with the command nmap 10.0.2.0/24. We can see our target machine has an IP address of 10.0.2.33 and has just two open ports, port 22, which is an SSH port, and port 80, which is an HTTP port. Since port 80 is open, we know this machine is hosting a web server, so let's take a look at it through our web browser. It takes us to a page for someone named Arsene Lupin, the gentleman thief. If we view the page source, it gives us some words of encouragement, but not much else. At this stage, we haven't really got much to go on, so let's do some directory enumeration. The way directory enumeration works is we first specify a target. In our case, that is the target machine IP address of 10.0.2.33. We then find ourselves a word list which contains common directories and file names. Kali Linux comes preloaded with lots of these, and I will be using one named common.txt, which can be found at user/shared/wordlists/derb. The directory enumeration tool then tries every directory and file name from that word list, sending an HTTP request to the server and analyzing the response. If the directory or file exists, the tool will receive a specific code, something like a 200 OK code. If the directory or file does not exist, the server will respond with a different code, something like 404 not found. In this way, we can build up a map of directories and files within the server. There are lots of directory enumeration tools out there, and which one you use really doesn't matter. I find that some work better than others in different cases, and it can often be worth running a couple of different ones to see whether they get any different results. For today though, we are going to use GoBuster. Use the command gobuster dir -u http://10.0.2.33 -w /user/share/wordlists/derb/common.txt. In other words, run GoBuster in directory enumeration mode on this URL and with that word list. We can see that GoBuster has found a robots.txt file. If you don't know what a robots.txt file is, I go into more detail in my Mercury video, but for now, just know that it provides instructions for search engines on what directories they can and cannot access. If we look at the robots.txt file in our browser, we can see that it has disallowed a directory called myfiles. The symbol at the start is the tilde, and is often used to denote the user's home directory. If we navigate to the disallowed directory, we get what appears to be a 404 error, but if we view the page source, we see that the page can be accessed, it's just been made to look like an error. The hints seem to be suggesting that there really is something to be found here, so let's try another method. We are going to use a tool called FFUF, which stands for Fuzz Faster You Fool. Fuzzing follows basically the same process I described earlier for directory enumeration. The advantage is that we can choose a specific segment that we want to replace with options from a word list. Remember what I said about using different tools for different situations? That's what we're doing here. Let's run the command ffuf -w /user/share/wordlists/directory-list-2.3-medium.txt -u http://10.0.2.33/fuzz. FFUF is the fuzzing tool. The -w flag lets us specify a word list, in this case the 2.3 medium directory list. The -u flag is to specify a URL, which in our case is our target IP address. Most importantly, you'll notice that we used the tilde symbol followed by fuzz. This is an educated guess, but we're making the assumption that other directories will follow the same format as the one disallowed directory we already know about. What we're doing then is replacing fuzz with options from our word list to search for hidden directories, but having them start with the tilde symbol. We see from our results that we have a directory called secret. Navigate to it in your browser using 10.0.2.33/secret. It brings us to a page with a note from IceX64, which we will note down as a potential username, and it tells us there is a hidden file somewhere within this directory containing their private SSH key. To find it, we're going to do some more fuzzing. We're going to use the command ffuf-wordlists/user/share/wordlists/directory-list-2.3-medium.txt -u http://10.0.2.33/secret/.fuzz-e.txt. This is very similar to what we did before, but let's talk about the differences. This time, we are only searching within the secret directory. We also added a dot before the fuzz. This is because hidden files in Linux are prepended by a dot, so we want to search through our word list, but try each of them as a hidden file. Finally, we used the -e flag to specify the file type we care about, in this case, text files. This generates quite a few results, but as we scroll through them, we come across one called mysecret.txt. Once again, we can view this in our browser by adding .mysecret.txt to the end of our existing URL. It brings us to a page with a long encoded string. First step then is to identify what encoding algorithm is being used. Let's copy the whole lot, paste it into the cipher identifier tool in decode, and hit analyze. It's encoded using base 58, so click on base 58, once again paste our long string, make sure our output is set to ASCII characters, and hit decrypt. With that done, we can see on the left that we have an SSH key. Let's copy and paste the whole thing into a text file that we shall call sshkey.txt. Okay, so we now have our private SSH key, but before we can connect, we need a few more things. First, we won't be able to use this private key in its current form, because anyone can view or edit it, and SSH keys will be ignored if they are deemed too accessible. Let's use the command chmod 600 sshkey.txt. This will give the owner, us, read and write permissions, and everyone else no permissions. Next, we have the private key, but we still need the passphrase. For this, we are going to use a password cracking tool called John the Ripper. We need to convert our private key into a hash file that John can use, and luckily for us, there is an existing tool to do this. Run the command /user/bin ssh to John sshkey.txt > This will generate a hash file from the SSH key. Next, let's crack that hash using John. Use the command john --wordlist equals /user/share/wordlists/fasttrack.txt hash. Normally, I would use a bigger word list, but the hint on the secret directory told us to use fasttrack, so we can save time by using that list. Sure enough, we can see that the passphrase is password, spelled capital P at 55W0RD ! With that done, we are finally ready to SSH into the target machine. We have a username, a private SSH key, and a password. Use the command ssh IceX64 at 10.0.2.33 -i sshkey.txt. Enter our terrible passphrase, and we are logged in as user IceX64. Use ls to list the contents of the directory, and then use cat to read the user flag. So we have user access, but as always, we aren't done until we have root privileges, so let's see what we can do. Let's see what can be run with sudo permissions using the command sudo -l. It appears we can run a Python script called heist as the user rscene. Let's take a look at rscene's directory with the command ls/home/rscene. It contains the aforementioned Python script, as well as a file called note.txt. Let's use cat to read them both. It looks like the Python script imports a Webbrowser module, and we need to find a way to exploit this and gain access to a secret file. There is a guide on how to exploit this module, and I'll put a link in it for it in the description, but we're basically going to be following that same method. The first step is to locate the web browser module that is being imported. Use the command locate webbrowser.py. Next, let's find the permissions for this module by using the command ls-la/user/lib/python 3.9/webbrowser.py. We can see that owner, group, and user all have read, write, and execute permissions. What this means is that we are able to edit this Python script in such a way that when it is imported with the heist.py script, it will run an edited version of this module and gain us some level of access. Let's open up the script in a text editor with the command nano/user/lib/python 3.9/webbrowser.py. Place your cursor at the very start of the file and use Alt-T to delete everything. Then we are going to insert our code for a Python reverse shell. These are standard command lines, and you can find all sorts of cheat sheets on the internet which you can copy and paste, making sure to change your host IP and desired port numbers. I have one already saved to a text file, so I'm going to paste that in, exit with Ctrl-X and Y to save. What's going to happen now is that when I run that heist Python script as the user rscene, which remember, I can do with sudo permissions without a password, it's going to import the web browser module and run it. Since we've replaced the contents of that module with a reverse shell command, it's instead going to reach out to create a connection. All that's left to do then is to set up a listener on my host machine to receive that incoming connection. In a new terminal, run the command nc-lnvp1234. In other words, run netcat in listener mode over port 1234. With that ready, let's go back to our target machine's terminal and run the heist Python script as the rscene user. We can do this with the command sudo -u rscene /user/bin/python 3.9/home/rscene/heist.py. If all has gone well, we should be able to see that on our listener, we are now logged in as rscene. Let's navigate back to their home directory with cd/home/rscene, then use ls-la to list all contents. Use cat.secret to reveal the password for rscene. Because reverse shells have a tendency to be unstable, I'm going to break the connection with the exit command and then use SSH to connect back in as rscene with our newly discovered password. We are now logged in as a different user, but we still don't have root permissions. All we have really done is move laterally within the system, not upwards. The advantage of doing this is that different users have different permissions. We know that isec64 was able to run the heist Python script with sudo privileges. Let's see what rscene can do by once again using the command sudo-l. This time we are able to run pip as sudo. The PIP binary can be exploited to do all sorts of things, including privilege escalation. I'll include a link on how to do all of these, but for now I'm just going to copy and paste the commands in. All that's left for us now is to verify we are root with the whoami command. Navigate to the root home folder with cd/root, list the contents with ls, and then use cat to read the root flag. And there you have it. We've completed the Lupin machine. So how did we do it? We did a network scan to find the target machine. We did several rounds of enumeration, including the use of fuzzing. We decoded a private SSH key and extracted the password by hashing it and running it through John the Ripper. We exploited our write privileges to alter a Python script and move laterally across the system, which in turn allowed us to exploit an executable binary and escalate our privileges to the root level. I hope you enjoyed this video, and until next time, good luck with your own hacking exploits.